Hey everybody. So we have a brand new pre-cal and brand new Math 4 course where some of the stuff is the same as we had before and some of it we've changed it and put some new stuff in, took some new stuff out. And one of the new things that's in here is our ACT prep section, sorry. And that section deals with three different types of information that will help you for the ACT so that when you take it again, you'll be prepared and you'll hopefully get a higher score. One of those sections is complex numbers. And so here, one of the things that hopefully you've seen this before, complex numbers deals with our eyes, imaginary numbers, and all the good stuff. So as we're going through this, I'm going to go through the information pretty quick. So with that, if you need to stop the video after watching it and write it down and then go back and watch it again, that's fine. Do that. So first off, we have the imaginary unit, I. And in other words, we call that imaginary number or imaginary unit as imaginary number. And pretty much I, as the wording up here says, I is just the square root of -1. Why is that an I? Because there is no such thing as having a negative underneath the radical. So -1, -2, none of that can be under the radical. So instead of us actually having that and stopping there, we went to imaginary numbers. Just as math. That's what we do. The mathematicians, we love that stuff. Now, with that, one thing you would see here, it says, if all that's what I is the square root of -1, then I squared equals -1. And then you probably are like, oh, I don't understand, like, what? So let's just do this part. So we're leaving space here. All right. So let's just say, okay, we're squaring I squared. What happens if you square I? Well, if I is square root of -1, if we square both sides, because whatever we do to one side, we must do to the other, so that the equation stays balanced. If we square I, that means we're squaring the square root of -1, which you should hopefully remember that the square root of a square root and a square are inverses of each other, so therefore they cancel each other out. So square and square root cancel each other out. So therefore you are left with just -1. So when we start working things out today and start figuring out the complex answers or solutions, sometimes we'll end with an I squared. But when we do that, we need to make sure we change it over to -1 and simplify that portion of it. So if we have an I, it stays I. If we have an I squared, it needs to be transferred over to -1 and then simplify it down. All right, so cool. So not bad. This is stuff that we hopefully remember. And it does continue on with I cubed, I to the fourth, all good stuff, but we're not focusing on that right now. All right, so let's move forward. Let's keep moving forward. Let's keep going. Let's keep swimming. Just keep swimming, swimming, swimming. All right, so the whole thing that we just said was talking about I, the imaginary unit. So now let's go really in depth a little more in depth with our imaginary number. And it says an imaginary number is any number, bi, where b is, and that's not bi, that's bi, where b is a non-zero real number, and I is the square root of -1. So in other words, b is a number, I is I, but it represents the square root of -1. So with that, this is your actual definition for imaginary numbers, all of this. So write that down. Make sure you have that for your vocabulary. But that's your definition for imaginary number. Any number, bi. So b is the number, I is the imaginary number, the square root of -1, where b is the non-zero, and then I is the square root of -1, like I just said. I just repeat myself. Why'd I do that? That's funny. That's so funny. All right, now, with that, we have bi. Now, one of the things that's important about that is bi comes in normally with another term, which are considered complex numbers when put together. So complex numbers are numbers that can be written in the form of a plus bi. Bi. All right, so with that, the rest of this stuff here is going to actually just be information. But the part that I need you to get for your next definition is this whole complex portion. So this is your definition that I want you to write down. for complex numbers. Because again, complex numbers are numbers that can be written in the form of a plus bi. So if it can be written in that form, then it's a complex number. If it's just I or a bi, that's an imaginary number. If it has the a in front of it or like something other than that, other than just bi, it's a complex number. All right, or a complex unit for number here, for the numbers. All right, so with that, there's some more down here that I'm going to just uncover. We're not going to really write anything about that really. And here, this is where it explains what A, B, and I are. So here we know A and B are going to be real numbers. So it could be 10, it could be 20, it could be 5, it could be 7, -2, -10, -1 million, any of that sort. A and B are just numbers, real numbers. And I is the square root of -1. It should be square root of -1, not square roots. Let's get rid of that part. Square root of -1. So they include all real and imaginary numbers, as well as the sum of real and imaginary numbers. So we can be adding them, we could be subtracting them. This could be a -4 plus 2i, or something like that. So it could have negatives, it could be positives, it could be a subtraction sign right here. So it's on cover all that, encompass all of that. Sorry, that's what I meant to say, encompass. All right, so let's keep moving forward. I think there's one other piece down here. It's really quick. All right, and this is where we come to our examples of imaginary numbers. I feel like there's something missing there, but let's find out. All right, so first off, let's take a look at the first one. And we're going to here just label what is our A, what is our B. And that's it. That's all we're going to do. We're going to label A, we're going to label B, and then that helps us out to know like what part is imaginary, which part is actually like the constants and all that good stuff. So with that first part, A, we know that -6 is going to be your A. Why is that? Because if we write this above it really quick, that means that -6 is in the A spot, and we know that B is going to be 4. So it's in the B spot. Okay, let's do this next one. And I was missing that square root right there. That's what I was looking for. All right, so this one, you'd be like, whoa, wait a minute. This one is written different. Like, I don't understand what's happening. Wait, the I's first. Why is the I first? I'm confused. You math people, you keep doing this to us. Let's just rewrite it real quick. The reason why we don't write it this way normally is because it kind of gets confusing of like, is the I underneath the radical? Is the I in front of the radical? So it's easier just to write the I in front so that it doesn't confuse you about what's underneath the radical and what's not. But we can rewrite it this way. And it still means the exact same thing. So here, A plus BI, BI. All right. So with that, A is going to equal -7. Sorry, that should be a +7. Sorry, not negative. My fault. This should be +7. And then the B is a negative square root of 2. And again, if you look at it here, this is a positive. That's negative right there. So that means you have to carry that with it. So just to pull this down really quick, so you can kind of see that step 2 really quick. So if we were to rewrite this one more time, if you'll let me write, that'd be wonderful. So if we can rewrite this one more time, let's do it purple. We can do 7 plus a negative square root of 2i. So that way it's the same thing. And so therefore negative square root of 2 is the same thing as b in the same spot. And we just rewrote it so that this and this match up. That's all. That's all we did. All right, and then here, that's one last one. Talk about A and B. So here, let me put a line right here so we can kind of distinguish which line goes together and which one doesn't. And so I'm going to pull this one down. Take this off. Pull it down. All right, and then we're going to talk about what's A and what's B, and then go from there. So A equals B equals. So if we look at this part, we can kind of tell that A is equal to A is equal to 0 because there's no A there. It'll be like A plus this part because that's the I, that's the bi, but there's no a there. So that technically a is 0, and then the b is that 0.5. Oh my gosh, that's so hard. All right, so let's go now to an actual example where we add it, and then we talk about subtracting, and then we'll multiply, and then we'll be done.